So based on our previous webinar on the D400, in this one we're going to show you live the D400. We're going to show you the parts of the D400. I'm going to give you a quick overview just like last time. So it has dual power supply. Those are hot standby power supplies. It has a main CPU, which is a PC104 compliant motherboard. It's a fanless CPU and comes with all the indicators for all the communication ports in the back and the network interface, the IRIC-B, and a power indicator, ready indicator. We have a front compact flash for the user log files that can be used. From the back, the D400 has 8 serial port cards interface. Each serial card will have 2 serial ports on it. So either RS-232, RS-485, a GFO or a PFO card can be installed. You have an IRIC-B input and an IRIC-B distribution. IRIC-B is for the time clock. We'll talk about that later. You've got an option for an Ethernet 4-port switch, whether it's copper, whether it is fiber optic. You also have the option of another COM port or another COM port with fiber optic connection, okay, or 10 base instead of the 100 base hot standby fiber optic. You have the option of a KVM switch card. The KVM switch card allows for a motherboard, a keyboard, a mouse, and VGA connection also for speakers to be connected for alarm sounding out. To connect the power, you've got 2 power connectors in here. This power connector on the left is basically, if you're looking at the D400 from the front, it will be for the power supply on the left, which means that if you're looking at both of them from one end, if this is on the left, it's feeding the power supply that's on the other side, the right, and if this is on the right, it's feeding the power supply that's on the left. There is a system failure power supply indicator, and that's basically would indicate when there is either a system failure or we have a loss of power to the D400. From our front interface, so we've got the 2 power supplies that are hot swappable, and then we've got a compact flash. From an indicator point of view, we have a power. When it is steady on, it means that it's receiving power. If it's off, it means that there is no power. So green solid on means we're receiving power. The ready, when it is on solid, it means the CPU has went through the initialization process and now it's ready to process communication either to devices in the field or to masters or local HMIs. The IRIC-B signal, when it is solid, it means that it's receiving the IRIC-B signal. So green solid means the IRIC-B signal is being received. When it is not there, it means there is no IRIC-B signal being received. The network, as we said in the first part, that there will be 2 network cards. The network activity would show up here. It will be green if there is a carrier detect. So if there is a solid communication, it means that we will see the link. And then the lower 2 indicators would be yellow to indicate activity. So they will basically show the transmit and receive activity. Then we have 2 USB ports. Those 2 USB ports can be used for a USB stick, and basically if you want to upload or download the communication or the upload or download files, you can attach your USB stick and then you can upload and download files. You can also do it via SFTP or Secure File Transfer Protocol. So that's basically how to use the USB with these ports. And there is an Ethernet port which is front dedicated for communication, front Ethernet port. There is a communication port. This is for maintenance, a serial port RS-232. You can use a null modem cable with it, or you can use if you're using a modem, then you wouldn't use a null modem cable, you would use a DCE to a DTE communication cable. For every communication port on the back, there is a transmit and receive indicator. So 1 to 16, like we said, 8 cards, each card has 2 ports, which mean that in total 16. So for the 16 ports, we can see that we have a transmit and a receive indicator. All right, and then when it is green, it means it's transmitting. When it's yellow, it's receiving. So the D400 is equipped with a compact flash in this slot, and the way the compact flash works is you remove the front cover, okay? And then there is a little button in here. We press the little button. And the compact flash would come out just like your camera. And this is a 16 GB compact flash. Now the thing about this compact flash is it has to have the same operating system as your main compact flash. So if you look closer at this one, this has a writing on it. It says SGA0002 version 3.2, and it's a secondary compact flash. The main should say SGA002 version 3.2 primary compact flash. It has been an occasion where a customer had purchased a compact flash, placed it in the D400 thinking it should work. What happens is we have to program these compact flashes in order for them to receive the data logs into the compact flash prior to installing the compact flash into the D400. So you'd have to receive these compact flashes from the factory in order to install them in the D400. Okay, so from a top view, you can see the 2 power supply position, and then you can see the main PC104 CPU, motherboard, and there is 2 compact flash. This compact flash is basically for the user log files, like I showed you how to remove it. There is a compact flash under this motherboard or mini motherboard that basically houses the operating system and all the applications. And as you can see, it's a fanless main CPU motherboard, so there is no mechanical moving parts, which is important in our substations. There is an interface card to the communication connections in the back, all the communication ports on the back, and this is the power supply interface into feeding power into the 2 power supplies. For an RS-232 communication port, we can have 8 card interfaces, as we said. Each one can have up to 2 ports. So I'm going to talk a little bit about the RS-232 card. When you pull out the RS-232 card, it looks like this. And what you will find is that there is switch 1, switch 2, switch 3, switch 4. Now, the COM port 1 is in the bottom, COM port 2 is in the top, right? So these switch 2 and switch 4 controls COM port number 1. And switch 1 and switch 3 controls COM port number 2, which is on the top. Okay, this is a common pitfall. Even though it's noted that this is port number 1, this is port number 2, it's common in the field to mix it around and say think that this is COM port number 2, this is COM port number 1. Okay, so let's go closer and start to talk a little bit about the switches. Okay, so we've got a DCE and a DTE device when we want to communicate on a serial port. A DTE device is a terminal device or a data terminal device, And a DCE device is a device that sits between the data terminal, so it's like a modem, right? So a communication device like a modem. So basically, if we want to set it for a DTE device, like if you're connecting this directly to a relay in the field, you would use a null modem cable. And to use that, basically on these switches here, okay, you would have to set it up such that it's all set up toward the numbers, so toward the A position. So this is the A position, this is the B position. According to the chart, if you want DTE, then I would set up number 1 to the A position, number 2 to the A position, 3 to the A position, 4 to the A position, 5. If you like, it's set up toward the numbers. So that's the A position. Okay. If I want to set it to communicate to a DTE device or a modem, right, then what I can do is I can set up all of this, the first one to the A position, second one to the B position, third one to the B position, first. So right now it is set up to communicate to a modem or a DCE device. Also switch 3 and switch 4, which in turn controls the COM2 and the COM1. For a DTE, it needs to be set up in a certain pattern. So for switch 3, if I want to set it up to a DTE, right, again, to where the numbers will be away from the numbers will be an on position, to where the numbers will be an off position. So I want it to be, for a DTE, it will be off, like you see it here. Number 1 is off, number 2 is off, number 3 is on, number 4 is off, number 5 is off, number 6 is on, number 7 is off, number 8 is off. If I wanted to connect to a DCE device like a modem, then what I would have to do is set it to to off for number 1, on for number 2, off for number 3, off for number 4, and then off for number 5, off for number 6, on for number 7, and off for number 8. Okay? Now, if we have an IRIC-B ground enable, then you would have to set it for off, 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 on, right? So number 1, number 2, number 3 are off, number 4 is on, and then number 5, 6, 7, and 8 would be set up to off position. Okay, so we talked about the RS-232 options. We also have an RS-485, and the RS-485 or the RS-422 are well known for allowing us to do a multi-drop. So you will communicate, instead of point to point, you will communicate from the D400 to many devices connected on the same loop to back to the D400. And this is the RS-485. We'll talk a little bit about the switches on the RS-485. So I'm going to pull it out, place it out here. Hopefully you can now see the switch that's available on it. And there will be 2 sets of switches. There is switches on the front here that we can see, and there is switches on the back of the RS-485. So I'll go back to the front of the RS-485 switches to show you the settings of it. So for the RS-485, we can set it for either a 2-wire or a 4-wire. Basically, you've got switch position number 1, switch position number 2. Again, the on position is away from the number, the off position is toward the number. So if I want to set it for 2-wire, switch number 1 would be on, switch number 2 will be off. If I want to set it for 4-wire, switch number 1 will be off, switch number 2 will be on. As you can see, in this case it's set up for 4-wire because switch number 1 is toward the 1, switch number 2 is away from the 2, as such it's on the on position. Okay? And that would control for the first port whether it's 2-wire, the second port whether it's 2-wire or 4-wire. I'm going to show you from the back the importance of the switches on the back of the RS485 card. These switches, okay, which is switch 3 here and switch 4 here. Switch 3 controls the top RS485 port. Switch 4 controls the bottom RS485 port. So this is controlled by switch 4, this is controlled by switch 3. For a switch 3, if we want to set it for RS485, we would set all the pins to the off position or toward the numbers. If we want to set it to RS422 120 ohm, right, not with a pull-up, pull-down resistor, without the pull-up, pull-down resistors, you would set up the first 5 to the off position and the last 5 to the on position. Okay, so 1, 2, 3, 4, 5 would be set up to the off position. 5, 6, 7, 8, 9, 10 would be set to the on position if we want RS422 120 ohm with a line termination on the transmit and receive. If it is RS422 120 ohm line termination with 680 ohm, then what, for that setup you would set them all to the on position. Okay, so the 3 settings that we have is either RS485, all of them are on the off position. RS422 with a termination, that will be half of it will be on the on position. The first top half will be on the off position. The bottom half will be on the on position. Or if we want RS422 with a pull-up, pull-down resistor, then all of it will be on the on position. The glass fiber optic and the plastic fiber optic, they have again the communication ports with the port on the bottom being the first one. As you can see, we've got the glass fiber optic for a 10 connection and the plastic fiber optic. So I'm going to take out the glass fiber optic card and the plastic fiber optic card. Now, as you can see, the setup of the switches on both of them is the same. Okay, the reason being is you can either have a transmit receive or a reverse on the transmit receive. So if I want a standard transmit receive, it's as you can see it here, toward the number is B, away from the number is A, so it is BA, BA, that would be a standard. If I want it to be inversed, or this is the transmit, this is the receive, then what you will have is AB, AB setup instead of BA, BA setup. Okay, so we finished the serial ports. We're talking about the IRIG-B. Basically, the IRIG-B connection is to allow the time to be received by the D400 from an IRIG-B device that's sitting in the substation. So the IRIG-B broadcasting device would receive the time signal from the satellite and then would broadcast it to the devices over an IRIG-B wire. The IRIG-B wire would connect to the D400 either using BNC, TTL, or fiber. So there is other ways, of course, the D400 can get the time either via simple network time protocol, SNTP. If you have other devices that needs to send the time, there's probably other devices that is not accommodated by the D400. Example, the HOP device, where you would need a HOP to IRIG-B or HOP to SNTP converter. The IRIG-B input card, which is this card, and this is the IRIG-B distribution card. So the IRIC-B distribution card would transmit IRIC-B to other devices. The IRIC-B input card, which is the receiving card, have 3 switches on it. So we have switch 1 here for the IRIC-B, and this switch basically controls whether the transmit is in standard form or in test mode. So in standard form is as you see it here. So like I said, pin 1 will be on, pin 2 will be off. So 1 away from the number 1, and 2 toward the number is off. So that's basically on, off. That's a standard mode. If we want to put it in test mode, we would set it for off, on. So pin 1 will be off, pin 2 will be on, which is the opposite of what you see here. Okay, so the next switch I'm going to talk about is switch number 2. For switch number 2, basically we've got 1, 2, 3 switches on it. On is away from the number, right? So if I have the first one to be on, basically that means that the fiber connection is on. If number 2 is on, then the TTL is on. If number 3 is on, then the BNC connector is on. So let's say I want to set on the BNC connector instead of the fiber. This is how would we set it. Now I am receiving communication via the BNC, not via the fiber connection. And this would allow it to receive it via the TTL, right? As we discussed. So I'll set it back to fiber. So that's it for switch number 2. Switch number 3 basically controls whether we are inverted or normal. So if this is received, this is transmit, this would be the setup. So pin number 1 will be the on position or toward the number, pin number 2 will be the off position or away from the number. If we want this to be the transmit, this will be the receive or the inverse of what is the norm on this card. Then switch number 1 will be to the off position, switch number 2 will be to the on position. We covered serial, IRIC-B. Next we're going to cover the Ethernet or network connection on the D400. Like we said, there is a network port on the front. There is 2 network switches, unmanaged switches. I get this question all the time, whether they're managed or unmanaged. They're unmanaged switches. Each has its own IP address, and this comes in so much variety. So the first one is 4-port copper, 4-port 100 base fiber. It's a hot standby. You can achieve hot standby with a fiber setup. You've got a 10 base fiber. You also have the option of getting another COM port, which is COM2, and this will allow you to connect to a DCE device like your modem. You have the option of getting a COM2 with 2 network ports, so that's like Ethernet and a COM2 connection. Okay, so again, 4 options. It's either 5 options. COM2, 100 base fiber, 10 base fiber, COM2 with copper, or all copper Ethernet connections. For the KVM switch here, or for a local HMI in the substation, you can have 2 USB connections, so a mouse and a keyboard can be connected. You can have speakers connected to your speaker output, okay? And you can have a VGA connection to a local screen or monitor. Now, the one challenge that I see all the time, I'm asked about this by the customers, is I went and I bought a VGA monitor that's a touch screen. Touch screens normally require certain driver to be installed on the device that's going to use this touch screen. So considering this is a packaged Linux operating system that you cannot add a driver to it in the field, you may probably, chances are, you may not be able to connect the touch screen and use the touch screen capability with the VGA connector. What you will need to do is get a fully featured touch screen that has its own operating system like Windows, and then it can communicate over Ethernet to the device, and this way you can achieve the touch screen capability if required in your substation.
In summary, the D400 is built in a modular manner, ruggedized for your substation requirements, whether you have a requirement for a dual power supply, serial, IRIG-B, Ethernet, or if you have a KVM requirement set up with a keyboard, mouse, video, and speakers to meet your requirements in the substation. Thank you for participating in this session.